Hey all, welcome to the second lesson for week 2 of Honors Math Theory. As you've seen in the calendar, we're really going to be doing 2 of these a week, plus then you'll have some work time. My goal for this is not to overload you too much. There will definitely be some, as we get into more and more proofs, where you want to spend that time, where you want to work through things and give yourself enough time to really do the proofs justice. Writing incomplete sentences, as I said in the last video, things like that. But for now, let's just embrace the fact that we might have some nice, easier first weeks. If you do have questions, of course, put them in the comments. We will have work days on Wednesday and Thursday, and I will get any of these that are nominated up to you. Just make sure that you've got 18 from 1.4 turned in by the end of the week. So if you've got your stuff ready to take notes, let's get started. Here we're going to talk about describe power sets of a given set and analyze their cardinality. So power sets sound like a very cool, complicated thing. And while they are very cool, they are not too complicated. They are the power set of A, which is written as script P, which is the closest I can get in my computer is this symbol. You'll see a little bit more fancy script in your textbook. So the power set of A, which is written like this, it is the set containing all of the subsets of A. So we looked at something similar in the earlier notes from here, but it's the set that contains all the subsets. So in this case, if it's asking to find the power set of 1 and 2, that's just asking for all the subsets of 1, 2. So we're going to start out similarly to when we're just listing all the subsets. We're going to say the null set, since that's a subset of any set, and then the one element subset, so the set containing 1, the set containing 2, and then in this case the set containing 1 and 2 together. So this would be the power set. Here you'll notice that we've included final brackets on all of this. The nice way you can tell if you're done is if you remember from the last lesson, the number of subsets is equal to 2 to the cardinality. So in this case, the cardinality of the set 1, 2 is 2. So I should have 2 to the 2 subsets. So in this case, I've got 1, 2, 3, 4. Check that off. I'm good to go. Now here it says, okay, find the power set of the set that's 3x, where x is a natural number, and 3 to the x is less than 10. So again, making sure that we're just interpreting this set notation correctly. So in this case, I'm going to start out by writing this all out. So here, we've got the power set of these multiples that are less than 10. So in this case, that would be 3, 6, and 9. We have a nice 3-element set. I've taken the time to write out all the subsets of a 3-element set. I will write these all out to check your answers, but pause now and just make sure that you're on the right track and compare your answer to mine. All right. Besides the fact that I went beyond my sort of made-up boundaries, the thing I want you to look at most when you're comparing your things with mine is make sure that your parentheses and brackets are in the right place. Some students I often find will drop the front and end brackets, or they will drop the brackets on the individual terms. They will just make lists. And while that is a helpful way to come up with the different subsets, in terms of your final answer, you want to have them listed out as sets within a set. And again, there's 3 elements, so you should have 2 to the 3rd subsets, or 8. So that's a nice way to check your answer. This is really helpful when it comes to questions like, what is the cardinality of the power set of the power set of the set we were just dealing with? And this is definitely one of those cases where you don't want to actually write out all of these, because basically what this is asking is, what is the power set of this whole set? Now, absolutely, you can have power sets of power sets. If I took this set here and I asked, okay, well, what's a subset of this? Well, the null set and 9. The null set and 9 and 6 and 9 and 3, 6, 9. These are all subsets, but you can see that this gets exponentially bigger. So we're going to go back to that same rule that we went over before. So the idea is that the cardinality of the power set of A is equal to 2 to the cardinality of A. And this is what it looks like written out algebraically. And so then here, if we have the power set of what we had, this is 8 elements. And this is then asking for the power set of an 8-element set. Now the cardinality of that, which is what this is asking for here, would be equal to 2 to the 8. And that's a lot easier than coming up with all those answers, because that would be 256, just using a little bit of calculator magic. I don't want to write all 256 subsets of this set, but I now at least know how many there are. Similarly, we can look at power sets of products from last week. So if we're going to extend our formula that the cardinality of the power set is equal to the 2 to the cardinality of that set, and if we remember from previous lessons that the cardinality of a product is equal to the product of the cardinalities, therefore that the cardinality of the power set of the product is equal to 2 to the cardinality of A times the cardinality of B, because this is the cardinality of the set. We can just plug it right on in. So that's going to help us a lot with this one, because again, it's asking about the cardinality, not actually writing out all the elements, which is just going to take a really long time. So here we have, this is our A, which we know then it's looking easy to see. The cardinality of A, B, C is 3. This one's a little bit harder. This is our B, and it says that X is a real number. X is in the interval, so this is not a ordered pair. This is the interval notation from pi to 2 pi, where sine of X is equal to -1/2. And what I'm going to do here is I'm going to draw out my unit circle. If you remember correctly, we've got pi here and 2 pi here, so we're only looking at this half of the quadrant, which makes sense because our sine value is our y-axis, so we're dealing with -1/2 here, and these are our 2 points on the unit circle. -1/2 here would be 1 pi over 6 past pi, so this would be 7 pi over 6, and then here would be 11 pi over 6. So then what we can say is that the solution here for B is the set of 7 pi over 6 and 11 pi over 6, meaning that the cardinality of B is 2. And the nice thing here with this picture is that it's nice to know that these are the 2 that they are, but if you could look at this picture, even if you didn't have it memorized, you would know that there are 2 elements, because you understand how graphs work. Now that we have our 2 cardinalities, the cardinality of the power set between these 2 would be, so the cardinality of A times B would equal 2 to the cardinality of A, which is 3, times 2, which is the cardinality of B, so 2 to the 6, which is 64. Again, feel free to pause, rewatch, ask me questions in the comments, nominate homework questions, or hold an appointment slot from the calendar in the course materials, and I will try to get back to you as quickly as I can. Have a wonderful day. I'll talk to you later.